study today part 3 of module 7, which is entitled Firmness and Flavor. Key drivers for fruit purchasing are, according to published preference studies, I mean consumers' preference studies, are price, in first place price, second place the origin of the fruit, third place the quality indicators. But at the same time, it has been proven that inconsistent quality at the consumer level kills our product. This has been already seen, for example, in peaches. Research studies have contributed to describe and measure quality attributes of fruit, like, for example, peach, apple and peach, in a European project very well known, which is called ISA fruit, and you can find in the web. We like to find in our fruit our preferred attributes. Is it too firm or is it too soft? I know you all have to understand that. So what's firmness? Firmness is a physical attribute that is similar to us. Maybe you understand it better if we say it is hardness. Physically it's not the same magnitude, but for us in fruits it's very similar. I will tell you. Firmness relates to the force we need to either deform or rupture the product, okay? So the force we need to deform the product, which is called the endocarp or the flesh, by our fingers in this case, and we can do that instrumentally too, and that is called the deformation test. Or we can relate firmness to rupture of the flesh, mainly by our teeth, and instrumentally we have a test that is the penetration rupture test. Also an observation. The sound that you hear in your own ears during rupture when you are eating a fruit influence a lot our perceptions of firmness, and they relate a lot with firmness. Let's go on. We like to as I said, to find our preferred attributes. The second area is sweetness and acidity is okay in the fruit I'm eating, I'm purchasing. Sweetness depends on sugar content, and you have seen this already in an earlier module in this course. It is due to glucose and fructose mainly, but also other sugars, and it's very variable in different species. Sugars are formed during maturation of the fruit on the tree until it's harvested, and then during the process of ripening, what we call post-harvest ripening, sugars may either stay constant or may increase for different species due to transformation of their content in starch. And we have different examples that we see later. Acidity, for us, in our perception, is due to various acids: citric, malic, ascorbic, by the way, related to vitamin C. The balance between sugars and acid is the base for a good taste of fresh fruits. Most of them, not all of them. But different consumers may prefer lightly different balance levels. And that is a way maybe to be able to offer the consumers different levels. This is not done in general right now. The balance between sugars and acidity is represented by an index. So we can directly determine sugars, which we call here soluble solids or degree bricks, using chemical measurements, in this case using fruit juice. So this is a destructive test. Sugars that we represent as soluble solids, SS, are determined very easily with a refractometer, and also that in fact it measures total solids, which is really dry matter, and we can also determine total solids by desiccation. Some fruits are determined in its sugars or in its total solids by desiccation. But we are talking right now of the refractometry degree bricks. Acidity is made by titration with NaOH. The sugar-acid ratio is a normalized index that is presented here is the relationship between Brix value by 10 divided by grams per liter of citric acid. Here we see how we do that. We have to squeeze a piece of peach, and we squeeze some drops of this on the refractometers we have here. This is a larger one, smaller one that gets in our pockets, and we can do this destructive test easily. We can also test indirectly sugars and acidity, and this is based on advanced technologies, which are non-destructive, because we can detect by NIR, near infrared spectrometry, the level of sugars that and much more difficult acidity in a whole fruit. Or we can also do complex modeling to modelize ripening progress and relate that with the stage of sugars and acidity of a specific fruit. This is based on pigment, and this is visible spectrometry. And looking also to their firmness evolution. So we have two areas, which is the advanced technologies directly on the fruits, or we can have many data and then modelize the possibility of how the fruit is at that moment. So indirectly determining the quality, the taste of the fruit. Here is some examples of what I'm talking now with spectra. We see that this is a light, and we have here some light sources. These are fibers, and we have here a detector. We put this on the fruit. In this case, this is an orange. I prepare that so that you see how the light that comes out of this instrument goes really to the end of the fruit, but without the skin. With the skin it is much more difficult, but it is also done. And from here we get, what we see here is only the visible part, so we are around this part. This is the visible part of the spectrum. This is explained largely in a different part of this module. And then we have here the NIR spectrum. As we see, there is discontinuities in the spectra, and we can from them know the internal quality, mainly sugars and water and acidity also, some other components of the fruit. Here we have the same thing. We are approaching some fibers, optical fibers here with the light, and this is on an onion. So onion is also very transparent, so we can put NIR very easily and see the soluble solids and total solids of onions. Testing firmness. How do we test firmness? We have said already that we have two types of tests, the deformation test and the rupture test. The deformation relates to our sensation when softly pressing the fruit with our fingers. And it is done with a testing instrument like we have here, where we touch and deform the fruit. Rupture relates to a sensation when biting or crushing. What we do is penetrate the fruit without the skin with a spherical indenter. And there are some protocols and some standard tests that we apply to this. I will show you. Usually, in testing fruit in a quality laboratory, already in many of the pack houses and so on, there are some samples taken, and there they determine size, weight, color and color distribution, firmness, and also juiciness. And so it is used mainly for doing a quality check of the product providers, which are the farmers. They go to the packing house with their fruit, and also for management decision of the industry, really. So we are going to approach very little the base of this test that we are telling here. It is very easy to understand, even if it is physics, and it is a Hertz theory that was developed already more than 150 years ago, and it is very interesting because it shows us very well what's happening here. Even if we are not going to calculate this, which I encourage you, everybody should try to apply for R0 this calculation of the stress. Look here, stress is represented by these small arrows. Where? In the area of contact. So we have here two spheres. They are getting in contact. They begin contacting in the center. As long as the sphere deforms the other sphere down, we have stress in an area based on the contact area, okay? And what these equations say us is that the maximum stress is found in the center of this area. If we see this in 3 dimensions, of course this area is circular when we have two spheres. Of course, we have a sphere in the indentor. We have not a perfect sphere in a fruit, but in fact this fruit is very nearly a sphere. There is different ways to do this test, but it is very clear that when we touch the other fruit, we compress it with a force P, we get stress in this area. The stress and the relationship between the force we apply and the deformation we get is exactly the test we will do. Maximum stress is the P, this, divided by the surface and multiplied by 1.5, which is at the center. Again, and we can do different measurements. We can have spheres-to-sphere contact, and we can also have flat plate contact. Theoretically and experimentally, it is proven that this is the best way to use an indentor to determine directly on a fruit its firmness, contact firmness. And this is what we get. We get what we call the transient elastic force deformation test. We are determining, thinking that the fruit is elastic, which is not completely true, but very nearly true. And so we apply a deformation, which is here. This axis shows us how the fruit is touched from the beginning here, and deformation goes on, and so the force that we are measuring here, the resistance force, grows. And here, this is the same thing, but it represents a different kind of graph. And the force goes back here. I'm not going to give any more details here, but what we know is there is a residual plastic deformation here. So the fruit is not completely elastic, but what we do is use this area. For many fruits, there are fruits that cannot be tested in this way. We have many parameters in this diagram that show us how the mechanical properties of the fruit relate to the firmness we are looking to. We have a very similar test for the penetration test that I told you earlier. So this is the penetrometer reading, but if we can determine deformation and force, and let me show you here some numbers, we see them better. We go up to 3 millimeters, maybe, or 5 millimeters, until the cylindrical probe really ruptures into the fruit. This is this point. So this, the resistance to penetration of this fruit, this kiwi, is around 35 newtons for a deformation of 2.3, which is in fact fixed. There is many handheld penetrometers and contact instruments that the industry uses to go to the field and see mainly the maturity of the fruits on the tree for harvest. So to improve our positive perception of fruit, we really usually look for something else, and this is aromatic volatiles, because they are part of what we call taste. They are a very important part. We have put into taste already, as you have seen, the firmness, the sugars and acidity, but also volatiles. Fruits produce volatiles in very high numbers. As an example, in apples, over 350 different volatiles. They include very different and numerous chemicals, but in fact humans and also animals, we are only sensitive for a few of them, and this comes from evolution, as many other things. And these we call aromas. If we are sensitive, we can sense them, they call aromas. But the rest of the fruit's volatiles are very important constituents of fruit metabolism, so that even if humans, we cannot sense many of the volatiles, which are not aromatic, there are many volatiles that I can measure with some instrumentation. We are not going to go further into it, but you may find lots of research and experimentation on the measurement of volatiles. Inside this area is what is called the olfactory testing and the electronical gnosis. You may have heard about that. Well, so to improve our perception of our fruit, you have to use your knowledge at purchase. Go for the best. Select a market that specializes on high quality fresh produce. The market, they should care to offer you only or also the best. Give you the possibility of select what you like best. And then there is something very important where consumers, we do not have a lot of control. And it is that the fruits that I am purchasing must be beyond physiological maturity. That means that they are able to ripen properly thereafter. Thereafter means after harvest. For this, the producer, the farmer, and the distribution are in charge. So producers, farmers, and distribution have to know very well, and they do, when they have to harvest their fruit. They always try to harvest their fruit as early as possible, but they should they should assure us that they are beyond their physiological maturity, so that we can have good fruit at home. As I said, regarding aromas, they only develop properly when fruits are led to mature on tree. Here it is the liaison. They continue evolving in post-harvest ripening, and they are related also to proper refrigeration, as I said. The volatiles, so some of the very important quality of fruits is related to refrigeration practice. I wanted to show you a little bit only on sensory panels. You can look at that. There is lots of literature on this. Sensory panels is persons that are used as reference for consumer quality studies, and is a big area of research. And sensory panels are, in fact, they are trained people who know how to mainly sense and describe what they are eating. And in this case, this is an example of tests we did in this ISA fruit, our ISA fruit project we had. And this is apples. So we have 10 little cups. These cups have each 3 pieces of apples. These apples are put in order, and these are 10, so we will have 10 assessors here behind these little windows. They get the cup, and they are not related between them, and they have to qualify with some descriptors that have to be established. These apples, they will be from different areas, and they qualified, them mainly for what we call mealiness, which is the opposite to juiciness. Then, as I said, we get the fruit, we purchase it, and we ripe the fruit at home. In general, we will not use instruments at home. We could, but more and more these are well known and used by the industry. We as consumers will rely on our own expertise that we will acquire along this course in the next module, module 7.4. So I beg you, stay on.